morning to all. Welcome to the course Environmental Engineering. As we are discussing about various water quality, water demand, and as well as water supply. This the point according to the water quality point of view, we usually talk about the physical characteristics, chemical characteristics, and as well as biological characteristics of the water. Then we can estimate the water quality, and then coming to the demand. The demand may be various purposes. For example, it may be a domestic purpose, it may be an institutional purpose, it may be a hospitality purpose, it may be a agricultural purpose, and fire demand. So, in order to reach the future demand, we need to calculate the we need to estimate the population, expected population in future. There are few methods that we are going to discuss in this particular topic. So our topic is today is population forecast. So whereas population forecast is nothing but for example, now if you want to estimate the population for the next 2 decades or for the next 4 or 5 decades, so there are few methods. Then accordingly, we can after getting that population in that particular decades, then we have a choice to design the storage reservoirs, and we have a choice to choose the appropriate diameter of the pipe for the water supply, and for various purposes also we can use that estimated population for extension of the roads and some construction of flyovers, the bridge reservoirs. In all the way we can use that population, expected population in coming 2 or 3 decades using various methods. That methods we'll discuss here in this particular lecture. So before starting estimating the population forecast, we are supposed to know what is the design period. So actually this design period is nothing but after certain 20 or 30 or 40 years. Generally, if you take construction of roads, they usually keep in their mind the design for 20 years plan. Like that, for every 20 years they will they calculate the population, they estimate that vehicle traffic, and then accordingly they design the roads. So here also in this case, in case of water supply and engineering, so the complete water supply projects includes huge costly constructions. Those costly and huge constructions are, we can say, dams, reservoirs, and treatment works, means treatment plant, and then network distribution pipelines. These are the various works actually required requires a lot of money for constructing these various dams and reservoirs. So then all these works can't be replaced easily, because for example, after 1 decade the population is increased rapidly due to the urbanization, and in that case if you want to change whatever the existing dam or reservoir easily, so it is not possible in that case. So similarly, their capacities can't be increased easily for future expansion. So whereas if you are while constructing the dam or reservoir or any treatment plant, while laying the distribution pipes, if you are not aware of the future population and future demands, so then there will be a lot of problem with because these are the constructions are very costly one. So without awareness on future population, if you construct a reservoir or dam, so it is not possible to change their capacity rapidly, and it is not possible to change their dimensions very quickly in order to reach the future expansion. That's why for for example, if you are constructing a reservoir, you must think about the reservoir purposes, then the catchment area in and around the reservoir, then that to be considered, and then we need to be estimate what is the water demand in future. So accordingly we supposed to take the design criteria in order to meet the future needs. So as extension or expansions in the water works, networks of pipelines are not easy work. As I told, these are the very costly ones. Suppose we are laying a water network line, so from some long distance to any metro cities, so it is not possible to change the diameter of the pipe, or not possible to lay the new line in order to reach the water demand in the metro cities. So while constructing only, we supposed to calculate the what is the expected population in coming days. I mean, in coming days, nothing but in after 1 decade or 2 decade. So then accordingly we are supposed to select the diameter of the pipe. Then it can, then it will survive for 2 to 3 decades without any disturbance. So because if you want to change here, again and again, it will be a lot, it impact on the economy of the particular state also. So then while designing a pipeline, and constructing these works, means various huge works, while constructing a huge work, they should have sufficient capacity to meet the future demand of the town. So here it is very clear, while designing a dam or reservoir, while pipelines must require a must in our we must the designer or the persons who are involved in that particular work, they must have a knowledge how this population get increased. And if it is a town, suppose if you are supplying a water to any metro city, in that case they must know um, the growth of the urbanization, they must keep in their mind. And then the industry growth and the population growth, they must keep in their mind while designing the pipelines and while constructing a water storage tanks and everything. So then they can those the constructed elements, they can serve for 2 to 3 decades without any disturbance. So the number of years of the number of years for which the design of the water works have been done is known as actually the design period. So for which for how many years we are design, before we usually fix for 20 years, 30 years, 40 years, that period is actually called as a design period. That period is actually called as a design period. So these periods should neither be a too short, whatever the design period, this neither be a too short or not be a too long. So even if it is shorter, if it is, I mean, suppose we are, for example, you say we are in 2020. So if you design this whatever the water works for by keeping the lifespan of those is 5 years, nothing but 25. So it is useless. So whatever the money we are spending on that, it becomes useless. Similarly, it should not be a too long. If it is too long, there may be a maintenance charges, maintenance cost may more uh, uh, than that particular time. So here, so that's why it is the whatever the design period you have chosen for constructing a reservoir or a dam, it should not be a too short and too long. Generally, in dams and reservoirs, they usually construct for by keeping 100 years as a design period, and other elements are very less. You can see here most of the waterworks, mostly the waterworks, water related structures like storage of tanks, that pipeline construction. So they designed for 20 to 30 years. So while compared to the reservoirs and dams, this waterworks design period is very less. So they commonly designed for 22 to 30 years, which is fairly good period. We call it as this period is fairly good period. So various factors. So the following factors we should keep in our mind while fixing the design period. So whatever may be the 22 or 30, 40, whatever it may be, while fixing that particular design period, that particular period, we must keep these things in our mind. One is funds. So suppose if you are you take two cases here. One is too short, the second one is too long, related to the funds. For example, in that particular year, suppose there is a very less budget for this water works. So suppose in that case, accordingly budget, if you design a design period for shallow period, I mean for short period, say 5 years or 10 years, like that. So then after 10 years, whatever the amount we spent on this water works, it becomes waste. The dimensions of those water work structures or water work pipelines may not be served for the demand after 10 years. So that so it is also one of the, I mean, presently it will work for the time being, but after 10 years it won't be work. So because why it is not working after 10 years, nothing but the population growth got increased, and the urbanization, due to the lot of urbanization, the industrialization, and the population got migrating people from different different corners to town got increased. So that's why after 10 years it is not it is not sufficient. The whatever the water quantity we are supplying to the people, it is not sufficient. If you select very uh, less a short period for if you fix the short period for design case. So second case, if you consider in these funds for too long, okay, you are well, you have constructed the, you have fixed the design period to serve around 100 years, to serve around 100 years. So that the element which you are constructing for 10 years survey purpose, for 100 years survey purpose, the entire cost of construction gets increased. So in this case it is not necessary at that time, so unnecessarily we are spending on that. So if you spend unnecessarily some huge amount on that particular project, the interest becomes on the project may increase. So again it will be a problem to the state survey. So that's why we supposed to keep all these points in our mind before fixing the design before fixing the design period of that particular element or structure. So here funds, then life of the pipe and other materials. Suppose if you are designed for 100 years, if you are if you fixed your design period for 100 years, whatever the material we are using in that particular construction of those elements may not be served for 100 years. So in between there will be a maintenance work is required. So that's why whatever the design period we are going to fix, it should not too short and it should not at the same time it should not too long. So then as I told, rate of interest on the loans will be increases if you choose a long design period. If it is long, the element sizes and everything is vary while compared to the shorter one. So that's why the material requirement is also more in case of longer designed oriented structures. So the cost of construction gets increased. Similarly, once if you apply the, I mean, if you got some loans, then the interest becomes increases. So that's why we should keep in our mind, for any water works, any water related works, the design period must be 22 to 30 years only. 22 to 30 years only. So this we need to keep in our mind. Coming to after completion of the after fixing the design period. So design period we must take care about the population forecast. You must take care of the population forecast. Where population forecast is nothing but very simply growth rate. We can say it is growth rate of the population for 2022 to 2030, 2040, that we are going to explain. So the population forecast is actually defined as the method of determining the expected population for a particular design period. So this design period is nothing but, as we discussed in the last slide. So the population forecast is defined as the method of determining expected. So this is not sure one. This is one only the expected population for a particular design period. So for example, if your design period is 30 years, for example, you say we are in 2020, the design period is 30 years, nothing but it is 2030. So till 2020 we know the population from the census data, but in 2030 we don't know the population. So that become whatever the population we are calculating at 2030, that is going to become a expected population. So this design period is 30 years. We are expecting the population for 30 years. So then accordingly we are planning the structures. We are constructing we are designing the structures like dimensions, so the material which we want to use. So then this is a design period. That's why the design period is very, very important. So here the population forecasting method is the method of determining the expected population for particular design period of a water supply system with the help of the study and analysis. This population forecast is required, some study and as well analysis. And next one is population projection is important since it helps the people, the government and as well as researchers make decision about the future. So for example, if you take roads, so then how this government will constructing the roads, they're changing from 4 lane to 6 lane or 2 lane to 4 lane, is depending upon the expected population only. Sometimes if there is place is not sufficient, they are going for the flyovers or underpass bridges like that. So this population also affect the useful to the government while taking the decisions. Similarly, researchers also. So for researchers also. So then for taking a number of decisions, the population forecasting studies are the most useful. And then, for example, if you take another example, construction of reservoirs or dams or construction of like your storage points, then depending upon the expected population, they can take the decision. Then it will survey for 20 or 30 years, whatever the design period. For that design period, they can survey. So here are some possible ways that people use the results of population for projection used to estimate whatever the population, whatever the estimated results the people may use it to estimate the basic needs of human, such as demand for the food, water, power, and transportation. So once after getting the expected population for next 20 or 30 or 40 years, then the government can arrange these things: food, power, water, and as well as transportation. So that I think it is very clear how these population forecasting studies are important in any case, not only in the water supply and water engineering. In any case, how this becomes important. You can see the governments and other researchers also, they can take the decisions easily. So then these are the various methods for population forecasting. The first one is the arithmetical increase method, geometrical increase method, and incremental increase method, graphical method, comparative graphical method, master plan method, and logistic curve method. So these are the various methods. So we'll discuss one by one. First, we'll start with the arithmetic increase method. So this method actually, this method is the average increase in population per decade. So in this method, the average increase in population per decade is to be calculated from the past census data. So till today we have the census data till 2011. So this is the recorded data by the government of India. So using this method, we are going to calculate population per next 20 or 30, 40 years. So in this, the average increase in population per decade is to be calculated. So for example, if I want to calculate it for 2021, before this period, I must calculate the average increase in population growth per decade. So then for 2001 to like this one 1991, like this, I supposed to calculate the average. Then I can predict the I can estimate the population forecast in 2021 using this relation, where you can see the growth rate of the population with respect to the time is constant in this method. So it is this increase in added to the present population to find out the population for the next decades. So this is the formula we will use. Here we'll fix the population with respect to the time is constant. This is one of the major assumption here, and where the rate of change of population with respect to the time is constant in this particular method. We must to remember that the rate of change of population with respect to the time is constant. So now, if you want to calculate the population for n decades, n is number of decades for any number of decades. So then this is the formula we will use, where it is p suffix n is nothing but population after n decades, whichever you want to calculate. For example, after 20 years, after 30 years, after 40 years, this n becomes changing according to year. So whereas p suffix n nothing but population after n decades. Here we are stressing the point decay. So here 10 years equal to 1 decay. 10 years equal to 1 decay. Suppose you want to estimate the population for the next 30 years, it become 3 decay only for the current year, from the current year. So whereas p is nothing but the present population. This present population will get from the census data. So from the census data. So this method is suitable only. Please remember that this method is suitable only for large and as well as old cities with a considerable development, not for the newly developed cities simply. So this is only suitable for the large and old city with a considerable development. So if it is used for small and average comparatively new cities, it will give some low results than the expected one, than the actual one. So that's why please remember that this arithmetical increase method can be used only for the large and old cities with a considerable development. So we can't apply this method for the new cities. So here the formula is to calculate the population in n decades. It is equal to P suffix n equal to P plus n into C. It is a constant where n is the number of decades. Then P is the present population. So we'll take one problem on this. The problem is actually, you can see here, according to the arithmetical increase method, predict the population for the years 2021, 2031, 2041 from the following population data. So this data, see now, population in 1961, 1971, 1981, 1991, 2001, 2011 is already given. So we need to be calculate. We need to be calculate here. We need to first take the average of the population growth rate. So then first we will calculate the increment we'll calculate the increment. So population increment. So now it is in year, then population, then increment. In 1961, it is this much is population is there, and similarly in 1971, you can see 1971, 10,15,672 is the population. Similarly, in 1981, 12,01,553, and again 1991, it is 16,91,000. These are the recorded data from the recorded census data only. This is for this data records are available. Then now we need to be calculate our increment for each decade. For each decade, till we have the last data we have known data is up to 2011. So the increment is here. The increment here there is no previous value for before 1961. Here there is no possibility to get the increment, and now it is the population in 1971 minus the population at 1961 will get the increment here. It is actually 1571.27, the increment in this particular year from this year to. And coming to the increment in 1981, for this we supposed to consider the reference as the previous decade population, that is 1971 population. So here it is 18, and then similarly for this the increment is 48.85, and then for 2001 with the reference to the 1991 decade, the increment value is 82, and then similarly for 2011 the increment is this much of population got increased while compared to the 2011 to 2001 to 2011. Now this average is the average increment of from all these 1, 2, 3, 4, 5, 6, from all these 5 decades, the average increment value is increment in population is equal to, this is the increment. So this in this formula, the formula of this arithmetical is P n equal to P plus n into C. P plus n into C. This is the population. In this formula we will apply and we will get the values expected population in population forecast in 2021. Once if you apply in this formula, it is equal to P plus n into C, where this we are going to be calculate. P equal to, this is the known value, that is 25,85,862 place. So this is the n we are calculating for 2021. We have the reference value till 2011. So 21 to 2011 to 2021, 10 years nothing but one decay. 10 years nothing but one decay. So here one this constant value we must the constant is plus constant value is 34 54 63. So once if you calculate this, we'll get the population in 2021. So it is equal to 29 25 29 3 13 25. This is the population in 2020. Similarly, if you want a population in 2031, 2031, so apply same formula, but here we'll get 25 85 862 plus 2031 we are calculating. So it becomes 2 into the average one, 2 into the average one, 2 into the average one, and here we'll get 26 788. This value once after getting calculation we get. If you want in 2041, then you just supply here, it is just apply here, decay is 3 and everything is same again. This is the average value and this is the p is the known value. Then in 2041 the expected population is this much. So in this way we are supposed to calculate the expected population forecasting. For example, if you are constructing any project, any waterworks related projects in 2011 for the old city, especially for the old city, if you are constructing waterworks like storage tanks, or if you are designing a pipeline diameter, all those things in 2011. So our design period, for example, our design period is 30 years. So then the city is old city, and the city have some constant development from the last few decades. So by keeping all those things in our mind, we supposed to select the appropriate method of population forecasting from all the methods. Then we will get, suppose if you apply this formula, this much of population we may expect in 2041. So our design period is 30 years. So this much of population is can be expected in 2041. So in this we are supposed to calculate the population forecast in this way according to this arithmetical increase method. So population at 2041 is this one. Then there is a one drawback. This method is we can use only for the old existing cities, but there is another method. This we can be used for the new industrial towns and which are beginning in stage of development. So this we will, in that case we will go with the geometrical increase method. Actually this method is based on the assumption that we need to keep in our mind. This method is based on purely an assumption that percentage increase in population from decay to decay is assumed as remains constant. The percentage increase from 2001 to 2011 or 2021, like it is from decay to decay is assumed as a constant. So the geometric mean increase is used to find out the future increment in population. Since this method gives higher value and hence it should be applied only for the new. So this method actually will give the higher value compared to the arithmetic increase method. So that's why here it is very particularly stressing that this method can be applied only for the newly developed and the cities which we are. For example, I can say here the capital region of Andhra Pradesh we can consider here. So because that is going to be developed newly, so we can use this method to estimate the population for the n number of decades. So in this, the formula we will use to calculate this one is P is affix n equal to, mean which year we want to calculate the population and where is the P is the present population. Still here also the present population is known one. That known one is according to our census. The known data is till 2011 only. And then this is the mean. Here it is the changes. This is a mean, geometric mean need to be calculated here from the previous records. So then present this, whereas P is nothing but present population, N is nothing but the which decade you are calculating. whether you want to decay wise only we'll consider here. That's why you will get 1 and 2 3 4 like that only. So again we'll apply the same method for the previous problem. For the previous problem, this is the previous problem. Now you see here also the same problem we considered till 2011. We are calculating, already we have available data. So then with this data, using geometrical increase method, we will calculate the we are going to calculate the expected population in 2041, 2031, and as well as 2021. So this is the data, actual previous data only. Then we'll solve the formula. I will write once again here. It is equal to Pn P plus n into all to the power of n. This will check 1 plus mean. This is 1 plus mean into 1 plus mean into. So this here we need to be calculate the mean between the two last with the known data. So here it is, we have the data 1961 the population, 1971 what is the population, still 2011 we have. Then again increment, the same increment values will get coming previous increment value. The increment value corresponding to 1961 is equal to 71. This we calculated in the last method. So directly I am just writing these values here. And this in 1971 the incremented value is the increment 1961 we don't have any increment value, because previous before 1961 you don't have any value, so that's why we won't get any increment value. So this is actually for difference between the increment between 1961 to 1971. So we'll get the increment in case of 1971 only, we won't get any value in case of 1961. So then again 1981 the increment value is 1858, the already calculated values only. And then 1991 the incremented value is 489985. And then 1991 2001 the incremented value is, this is the incremented value. And then 2011 incremental one is 42. So 5. So then till this get this incremental value, the previous method only, but the new method is the geometrical increase in rate of growth. Geometrical increase in growth, how to find that one? This one divided by 157 divided by 185811. So here we'll get the once after substitution you will get 0.18. So similarly for all these, if you do 1858, this is 85. Sorry, this is a population actually. This is a population in 1961. That is 8,58,545. So similarly, for if you want to calculate for 1981, because here we won't get any value. If you want to calculate for 1981, again it will be population at 1981 is divided by the increment value at 1981 year divided by the population at 1981. Population at 1971 just before decay to this one, that is 672. So we'll get here it is equal to again 0.18. Similarly here we'll get 0.40 for this decay, and for 2021 for 2001 decay it is 0.23. And then for this one is 2011, the value of geometrical increase in rate growth is 0.24. Now we need to be calculate the mean. The formula says that only. You can see here the formula is geometric mean we need to be calculated in terms of percentage. So then to calculate the mean value, it is equal to geometrical mean, it is 0.18 plus 0.18 plus 0.40 plus 0.23 plus 0.24 divided by 1 by 5. Once after substituting, then we will get 0.23 0.235. So in terms of percentage, it becomes 23.5 percentage. So this is the mean value. Now this mean value we need to apply. We need to be applying in the if you want, we are going to calculate the population in 21, 31, 41. So this the same formula here I'm using. So this is population at 21 equal to population at 21 is equal to again just simply that known population is 2011. It is I'm just removing this the till increment, and population I'm calculating for 2021. From before this, the 2011 is a known decay value, that is equal to 25,85,862, and then the population in 21 from this method it is equal to 25,85,862 62 into 1 plus this is a value that we obtained number of decades. This is for one decade because 2021 to 2011 10 years it is one decade only. Here we'll get the answer is 31,954. So this similarly we'll get for 2031 the expected population using this using this method it is 21, and similarly for 41 the expected population here it is 48,70866. So we need to be change only this value. For example, if you are calculating for 2031 it will be 2, it become 2, and for if you are calculating for 2041 it become 3. So remaining is same. So in this way, we supposed to calculate the population forecast using this graphical increase method. So the only the difference between the graphical to increase this method is in incremental increase method is there we calculate the difference between previous decay to the decay which we are calculating. So but here after calculating the differences, we will take the mean of those decades, and then we'll apply in this formula. We are calculating the we are expecting the we are calculating the expected population in any decay using this formula. So this is very important because as I told in the beginning of this lecture, many government agencies or researchers usually take the decisions based on this expected population only. So there you can remember that this method, the arithmetical increase method, can be used only for the old and with the cities which are constantly developing from the first few decades. So because this if you use the graphical method in this geometrical method for the old cities, it will give higher values. So that's why it not we not use the for in that case. So this method we can use for the newly developed and as well as newly constructed new cities like Amravati. So with this, I am closing today's lecture. We'll discuss the remaining methods and we'll solve some few problems on those methods in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.